talking about a shark and the alarm bell that goes off, or the siren that goes off to warn swimmers. And we're told that the intensity of the sound, which is notated as I, is inversely proportional to the square of the distance. So that means that I is proportional to the inverse of the square of the distance, and we would write that as 1 over d squared. And we're told that it's known that a distance of 1.5 meters has a sound intensity of 4. So knowing that pair, that's the pair that we're always looking for, the kind of two pieces of information that go together that help us to find the equation. So we're told that when I is equal to 4, d is equal to 1.5. And you'll always be given that pair of information when you have a proportionality question. So we know that I, instead of saying is proportional to, we can replace this with just an equation with an unknown that we're trying to find. So we know that I is equal to k over d squared. And we know that when I is 4, d is 1.5. So 4 is equal to k over 1.5 squared. And if we use our numeric solver, we can then find that k is equal to 9. And you can just use numeric solver there. That then tells us that we've proved the equation. Okay, so we've now found that k is equal to 9. So that's just a normal proportionality kind of start of the question. We're first of all finding what is the relationship. We're writing it in terms of k. We're substituting in our pair of information, and then we're finding the final equation, which in this case they actually told us and we were trying to get to at the end. In terms of the marks, you would get 1 mark for this part here for knowing that it is the equation of k over d squared, and then 1 mark for showing that you've substituted in to find k. The second part, you then have to sketch the curve on the axis, and you have to show clearly the point 1.54, which is that point that we used in part A. So I'm just going to go to my graphing calculator here, and even if you couldn't answer the first part of the question, you could still answer this part. So I'm going to add in a fraction, and it's 9 over, and then instead of d squared, I'm going to write x squared because my calculator doesn't know d. And I have this kind of a function. I probably should change it so that it goes from 0 to 6 and from -5 to 20. So I'm going to go from, instead of 0, I'm actually just going to go from -1 because I know that if not, the axis can actually disappear. So the x is from 0 to 6, this bit here, and then the y-axis is -5 all the way up to 20. And I can now see what my axis looks like, or what my graph looks like, and it kind of comes in like this and then has this kind of asymptote value. And I need to label on the point 1.54. So 1.54 would be somewhere around here, and you can label that point on. And then for part C, it says, while swimming, Scarlett can hear the siren only if the sound intensity at her location is greater than 1.5 times 10 to the -6. Find the values of D where they cannot hear the siren. So for this section, or for this part of the question, what I'm essentially asked for is when is the intensity greater than 1.5 times 10 to the power of -6. And we also know that the intensity is equal to 9 over d squared. So if I write that out in decimal form, So I have 1, 2, 3, 4, 5, 1, 5, there we go. So that is this number here, just written out again. And that is equal to, 9 over d squared. So now I'm just trying to find what is that d value. And I can use my calculator to solve it. I already have plotted here the graph of 9 over essentially d squared. So now I want to know when is that equal to 0.00000015. So this is 1.5 times 10 to the negative 6. 1, 2, 3, 4, 5, 6 if we hop our decimal place. And now I want to find what is the value of this point here. Now it may be that it's actually off my graph, so I'm now just going to change my x maximum to be, let's try 30. And I want to find where is that intersection. So I'm going to do intersect. And I'm not actually sure where it is, it's hard to see. So I'm just going to select up here. Okay, and there's no intersection found. So in that case, I'm going to go back to my window and I'm actually going to change this to be, let's try 100. And because of that, let's just change the y scale to be 1. The reason I've changed my y scale is because clearly I'm looking for this value of 0.0000015, in which case I don't need to be looking too large. So let's see if we can find where the value is here. So the intersection. So let's try somewhere around here. Still, there's no solution. And what I could do is actually, let's go into the table of values. And yeah, we can see we've got to go much, much bigger. Okay, so let's just try a few values here. So if I go back to my, if I go into my window, let's just try like 4,000. Let's go a lot bigger and see if we can work out what's going on here. And I'm just going to look for my intersections. And there we go, we've got one. So the intersection there is at 2,449. So 2,449.49 meters. So I could actually write that as kilometers. So that is 2.45 kilometers away. So when she's 2.45 kilometers away, she can hear the siren. If it is further away than that, then we cannot hear the siren, in which case she would not hear that there was a shark approaching. So for this part of the question, there is 1 mark for realizing that you needed to equate these two things, and then a second one for the answer. So notice on this question, even if you weren't sure how to start it, you could still have graphed it and got the 2 marks because they gave you the equation here. And you could actually still answer the last question as well, because we know that it's just substituting in the y value to be this. And then you could solve that on your calculator. Even if we couldn't find this, we saw here it's quite hard. Even just by writing that, you would still get the 1 mark. So it's always worth checking through and seeing where you can pick up marks.